Take a moment to pause this video to read its full problem statement. In this example, we're trying to convert a large number, 10 to the 50th power, to see if it makes sense in the context of this problem. And as we convert this number, we're going to use some common conversion facts, such as there's 1 hour is the same as 60 minutes, 1 day is the same as 24 hours, and 1 year is the same as 365 days. So really, we can't quite answer this statement just yet, even though it comes first in the problem. What we first need to do is put this number in perspective by thinking of it in terms of time. So 10 to the 50th power is the number of commercials, and let's assume that a TV commercial is about 1 minute long. So in other words, it would take 10 to the 50th power minutes to watch 10 to the 50th power commercials. So you see that unit being used right here, 10 to the 50th minutes. Now, what you see next are the conversion facts arranged in a way so that each fact, the numerator and denominator, are equal. And the reason we do this is because 1 hour, again, is the same as 60 minutes. And if you're dividing something that's exactly the same as itself, it's essentially equal to 1. And then we can multiply anything by 1 and not change that thing, that original thing. So that's what we're seeing right here. That's why we have, for instance, this conversion fact first. And it didn't have to necessarily go in this order, but there's an arrangement that has to happen with this conversion fact. So here we're given the number in terms of minutes, and notice that minutes must be in the denominator of that conversion fact. And the reason why is because a value in the numerator that's the same as in the denominator, we can cross out like this. Those units we can do that with. And the same happens with the next conversion fact. So first, let's analyze what this fraction really is. It says 1 day over 24 hours. Remember, that's a statement that is equivalent. 1 day equals 24 hours. So again, this number is essentially 1. So that's why we can multiply by 1 and not change the original amount. So what we're going to do is look for any units that cancel. Again, hours is in a numerator, hours is in a denominator, so those units can be crossed out. And then there's one more conversion fact here. Again, 1 hour, or 1 year, sorry, is the same as 365 days. So this is essentially 1. And then we look at any units that can be eliminated. So days, those can be eliminated because one's in the numerator and the other is in the denominator. And we did something similar to this when we were multiplying fractions and we crossed through common factors. So the next thing that we do is we're going to multiply this fraction, the actual numbers together. And if you need a denominator for this value, you can always place it over 1 just to see it. But we multiply all the numerators together. So 10 to the 50th times 1 times 1 times 1 gives us 10 to the 50th. Over 1 times 60 times 24 times 365. I'll get my calculator. And my calculator says that is 525,600. And the only other thing left here is this unit years. So our final unit will be in years. So next we can put this in our calculator. So I would recommend using the fraction key because this ultimately is a fraction right here. So I press the fraction key. In the numerator I have 10 raised, and here's the exponent key, to the 50th power. And you see that little right arrow is to lead you out of that, that spot. that like superscript, you could say. And you can continue to press that right arrow to get to the denominator. And here we get this number already in scientific notation. I believe we may have been asked to round to like 1.9. So that's why you see in the answer 1.9 times 10 to the 44. And again, the final unit is years. Well, 1.9 times 10 to the 44 is the same thing as 1.9, but that decimal moved 44 places. I don't even have no space. To the right is a ridiculously large number and way more years than we have on this earth to watch TV commercials. So that's when we can return here and say that this statement does not make sense.